David doesn't. So, good morning, student. Today's topic is Ethernet framing. So, Ethernet framing, that means we are talking about the second layer of OSI model. Because in the case of physical layer, we transfer the data in the form of bits. If we are talking about the second layer, that is data link layer, that means we are talking about the data transfer in the form of framing, is in the form of frames. So we have next, this is a basic information to what different IEEE method we use in the case of data transformation in the physical mode. When we are talking about the physical medium, that means we are talking about the IEEE 802.3 standards, because IEEE 802. Having different types of standards from 802.12 onward up to 15, 16, 20, 25. So when we are talking about the Ethernet framing, that means we are talking about the IEEE 802.3. And when we are talking about the wireless medium, on that time we are talking about the IEEE 802.11. 11 that is specified for the wireless medium, and 3 that is specifically for the physical medium, when we are talking about a physical medium. So these are the objective, because when we are talking about the physical medium, on that time we need some kind of addresses or data link layer that work with MAC address, because MAC address is 48-bit MAC address. So just wait, I'm just so if we are talking about the MAC address, so that is 48-bit address, and 48-bit that is further divided into two categories. Talking about the 48-bit MAC address. 48-bit MAC address. So 48-bit MAC address, that is further divided into two categories: 24 and 24-bit. So first 24, that tells the manufacturer brand from which the MAC address is, who developed the MAC address. That is first 24. And second 24 is the address of your system. That is deploy a particular address to physical address to your system. This is unique address. MAC address is unique address, worldwide unique address. We cannot change our system's MAC address, but we can spoof our system's MAC address. We can change MAC address, but temporarily, not permanently, with the help of different types of software. So one of the software that is TMAC. So TMAC is a software that provides a facility to spoof your MAC address. Spoof that is temporarily, you can change your system's MAC address. After rebooting your system, then you will get your original MAC address. Okay, this is physical address. We cannot change. We can spoof with the help of different types of softwares. So next we have different types of managing network communications. If we are talking about the different manages, so we have TCP/IP, ISO, Novel, IBM. So there are basically two models, TCP and OSI, that is ISO. So TCP that stands for Transmission Control Protocol. ISO, that is International Standard Organization, that provide facility. OSI, that is open source. Then next, this. So first we know what and why we use these protocols. because these all are the protocols. Why and what and why the use of these protocols. So suppose we want to communicate with two PCs, we need one protocol. Why we need one protocol? Because we have to understand the language between two PCs. We have to read the information from the destination, and we also reply with same format. So mostly we use TCP/IP because TCP is an implemented model. So OSI is only for a reference model. OSI is only for the reference model that is not implemented, just reference only. Okay. So novel, that is another protocol that use IPX, SPX models. That is 1980s, not much popular. So similar with TCP/IP, that is not free of cost everywhere. Novel is not free of cost for everywhere. So next we have the IBM. So IBM, that is SNA, is also equivalent TCP. But IBM use this network for internal reference only. IBM, that is implemented, but that is specifically for IBM and for internal use only. But for internet, they use TCP. If they want to communicate with other network, in the case of IBM, on that time, they will use TCP/IP. So here SNA, that is System Network Architecture. So Novel and IBM are proprietary models, and OSI is a just reference model, and TCP/IP is actual model that is working. So next we have the layered model TCP. Layered model TCP. So based upon three models, we have different standards also. So TCP/IP is not a numbered model. First of all, I'm just going to explain in these, because if we are talking about the OSI model. We are talking about the OSI and TCP. If we are talking about the OSI, that is only a reference model, specifically for reference only. And this is implemented model. OSI is having a 7 layers, and TCP/IP is 4 layers. Okay, so these 7 layers that work from top to bottom and bottom to top. When we are sending the data and receiving the data, they explain the top-down approach, then one of the from bottom-up approach. TCP/IP having 4 layers. OSI layer that shows the number. Suppose first layer is physical layer in the case of OSI. Second is data link layer. Third is network layer. That is why we are saying OSI is a numbered model. But TCP is it's not a numbered model. As shown in the PPT, they're not showing that it's a first layer, second layer, third layer, fourth layer. So that is why we are saying TCP is not a numbered model. Okay. So on the other hand, OSI is a numbered model, as I explained. So next we have the encapsulation part. So this is the layered model of OSI. Here we just explain the numbered layer. So first layer, that is physical layer, that transfer data in the form of bits. Transfer data in the form of bits. And after that, because when we are talking about the physical layer, that means we are directly connected with the physical medium with our destination. Okay, so data transfer in the form of bits. And when we are talking about the data link layer, when we are talking about the data link layer, and on that time, a data transfer in the form of frames. And when we are talking about the network layer, so that means our data transfer in the form of packets. Data transfer in the form of packets. Okay. Then transport layer. Transport layer that work with two different protocols. One is TCP, another one is UDP. UDP that stands for user data protocol, and TCP that is transmission control protocol. UDP and TCP. There is a difference between TCP and UDP. In the case of TCP, if you are talking about the TCP is getting or sending acknowledgement to your source. That means when we are talking about the TCP, that means we are talking about the acknowledgement part. Biggest example, when we are sending ping command to any destination, we will get reply back from destination, your packet is transferred. So that is under TCP. Because TCP work packet by packet. It send one packet, second packet, third packet, then first packet, then information about if they send, we will get reply back from the destination. Another example in the case of TCP, when we are sending email, to anyone, after click on the send button, we will get acknowledgement. Your data, your email is sent. That means we are getting acknowledgement from our destination. Okay, so this is called TCP. Next, that is UDP. They cannot send packet by packet. It will send 8 packets parallel to the destination. 8 packet parallel. So that is why we are saying UDP is faster as compared to TCP, because TCP that work packet by packet, and UDP that work with 8 packets. They are sending 8 packets simultaneously to destination. Biggest example under UDP, that is gaming, online gaming. So online gaming is a best example in the case of UDP, because we just only need the speed. When we are talking about a gaming part, online gaming, we need only speed. So that is why we always use on that type UDP. Okay, TCP, again I am going to explain. TCP is packet by packet transmitting data, and UDP, we just send, we need a speed, because in the case of UDP, we are not getting acknowledgement from the destination. We just want speed. We just want to send the data to the destination. Whether they receive, whether they deny, whether packet loss, hardly matter in the case of UDP. But it matters a lot in the case of TCP, because they required acknowledgement. They need acknowledgement. They transfer acknowledgement. Okay. So after that, we have session layer. Session layer that only maintain the session between you and your destination, and presentation layer, they only work with the data formatting and encryption and decryption. So application layer that work directly with your users. So next we have the encapsulation part. So in this encapsulation part, they work from top to bottom. So in this case, transport layer that include detail of TCP and UDP number. TCP and UDP number. And what type of different numbers are there? That is port numbers. If we are talking about the transport layer. Because as just see in application layer, there is only data. In the case of application layer, as shown in the picture, in the application layer, there is only data. And after that, we are talking about the top-down approach. After application layer, we have next layer, that is presentation. So presentation layer there is only a data. After session layer, you can just see there is only a data field. But when we are talking about the transport layer, one additional frame that will be added. Suppose this data, one additional field is added in the case of transport layer. So what does it mean? It includes the whether you are using TCP, whether you are using UDP. That tells the port numbers of source as well as destination. Port number of source as well as destination. Okay. So after transport layer, another field will be added. So this is the data plus port number. Again, one additional field will be added in the case of network layer. And what does it contain? It contains the IP address. It contains the IP address. IP address for whom? IP address for source as well as for destination. In the case of network layer. Then after network layer, we have another layer that is data link layer. Again, data link layer add one more field. And this field that contains the physical address. Physical address, that means we are talking about the MAC address. IP address is a system's logical address. It can't be changed. MAC address, that is your physical address. In the case of data link layer, our physical address will be added. Physical address with source as well as for destination. After that, we are having next layer, that is physical layer. The physical layer, and that data transfer in the form of bits. Data transfer in the form of bits. Whether your bit is 0, 1, 0, 1, 0, 1. Because our system only need the language 0, 1, bit by bit. So this is all about the encapsulation part. So after encapsulation, we have another one is de-encapsulation. Just wait, I'm just going to. So I think de-encapsulation slide is missing, but de-encapsulation slide that work with opposite of encapsulation part. Opposite of encapsulation part. Encapsulation that work from top to bottom, and de-encapsulation that work from bottom of it. Work with bottom of it. So after that we have the communication between end-to-end communication. So end-to-end communication, that means we are so first thing you have to know that is we are on a network data link layer. So that means data transfer in the form of frames. Data transfer in the form of frames. So frames means frame would have header of data link layer, network layer, and also have transport layer. So but packet would have only headers of network layer and transport. So similarly, segment transfer and transport, and it contains the session. So all layers are only add header, but data link layer add one trailer field as shown in the diagram, header as well and a trailer field as well. So what does it mean? What is the role of a trailer layer? So role of trailer layer, that is CRC, that is specifically for checksum. So it maintains the integrity of the data. Checksum, it works with the checksum and maintains the integrity of data. If error in data field, if error in data field and trailer field help to find out the error. Trailer field helps to find out the error. That is the rule of trailer field. Because only this frame header, data link layer, all the layers are contained the header field only. But in the case of frame, In data link layer, they contain one another field, that is trailer field. What the role of trailer field is to maintain the integrity of data. If error occur in data field, the trailer field will help to find out the error. So next we have frame format. So we have two different types of frame format. One is Ethernet 11 or 11. Another one is Ethernet 802.3. Ethernet 11 is developed in or worked in 1982. And after a year of 83, we will get sorry 802.3. So see first field in the case of Ethernet 2, that is DMAC. What does it mean? DMAC, that is destination MAC address. So DMAC, that is specifically for destination MAC address. Next field in the case of Ethernet 11, that is SMAC. So again SMAC, where S that stands for the source MAC address. Source MAC address. And next that is the type field. So type field, to find that when you de-encapsulate on other end, so read header one by one. So type field that indicate what would be the next header layer, or we can say that would be the next protocol in the case of type field. So next field we have, that is data field. Data, that means your data in this field. And after that data, we have field that is FCS. FCS, that is frame checksum. Frame checksum. Again, that checksum, that means specifically for the maintain the integrity of the data. And same as it is IEEE 802.3. Again, first field, that is DMAC, that is destination MAC address. And 802.3 is we having next field, that is source MAC address, and next one is length. So length field, that tells the complete length of your frame. Then after that, we have the field of LLC. LLC, that is specifically for logic link control, LLC field. So basically this is for service access points, because they doing mapping with the help of different controls. So next we have, that is the SNAP, where SNAP, that is subnet access protocol. Okay, and after that we have the field of data. And data, after data we have the field that is FCS. Again, that is specifically for the checksum part. So before, so frame format, after frame format we have the Ethernet 2 frame. Now they are going to explain each frame in depth. So in this we have a field again. We have a first field, that is destination MAC address in the case of Ethernet 1 frame. And after destination MAC, we have 6 bytes address field that is specifically deployed for source MAC address. Then after that, 2 byte field that contains the type field. Again, we already explained this type field. Then again, we have the data field, FCS. So in this case, one term is used in the case of Ethernet 1 frame, that is maximum transmission unit. So maximum transmission unit size, that should be 1500 bytes. Then after that, then after this, we use one of the protocol, in this case, that is ARP. So ARP that basically work with the data link layer specifically, and ARP that stands for Address Resolution Protocol. Another protocol we use in the case of this, that is IP. IP, you people know about that. It's internet protocol that work in network layer protocol. So next field we have, sorry, next frame we have, that is IEEE 802.3 frame. Again, in this frame format, we have 6 bytes destination MAC address, 6 bytes for source MAC address, 2 bytes for length part. So again, I'm going to explain this length part, that field that indicates the length of the frame. That means how much the size of data field and header field in the case of length field. Next we have, that is LLC. LLC field that contains 3 bytes and 3 bytes divided into further different categories. One of the first byte that is specifically for DSAP, DSAP, and second one is SAP, that is Subnet Access Protocol, and one of the field that is control, and D and SAP that is specifically for Subnet Access Protocol, that is specifically for destination and as well as for source, and 1 byte for control field. And next field we have SNAP field. So SNAP fields that tells the, again, Subnet Access Protocol. Again, they are divided into 2 different categories: organization code and type field. That work with the STP, that is the spanning tree protocol. And after that, we have field that is data field. Data field that contain the data. And next we have the FCS. FCS that we already explained. This is specifically for the frame checksum. And after that, we have the frame forwarding. Frame forwarding, as shown in the picture, we have 2 PCs and host A that wants to send a packet, data to host B, and host A is having an address of MAC address this one, and another one is the destination MAC address for this. And again, same, they first send the destination MAC address. If they already work with each other, then they will directly send the MAC address to the destination. If they don't know about the MAC address of the destination, on that time our system's MAC address is all F. All F. That means our packet that will be broadcast. It means I don't know about my destination's MAC address on that time, but we have to assign one MAC address to the particular frame. That means on that time, our system's MAC address will be all F. That is specifically for the broadcast MAC address. So next field we have the Ethernet MAC address. So in this, again, I already explained this thing, that is MAC address is divided into 2 categories. Because it is 48-bit address, 48-bit further divided into 24 and 24-bit. Now, where we will get our system's MAC address? So we will get MAC address from NIC card, that is read-only memory. It cannot we cannot change our system's MAC address. And if we want to check our system's MAC address, how we will check? I will explain. I'm just going to open command prompt. So there is a command for getting system's MAC address. So command for that is get MAC. You just write get MAC and press enter key. You will get MAC address for your PC. So see, there is the MAC address A4AE127B72OE. So this is a MAC address for this PC where I am sitting. So this is the physical address of this PC. So now again, if you want to check your system's IP address, there is a command for IP config. Sorry. So IP config is a command for checking our system's IP address. Our systems. What is IP address for my PC? So see, there is IPv4 address 172.16.228.64. There is a subnet mask address. We will learn how it will deploy to this particular IP address. But if we want to manage subnet mask address, how we can manage, we will explain in our next topic. That is specifically for the IP address. Here we just explain the MAC address. So next, I'm just going to explain more about the MAC address. So first, 24-bit, that is OUI, where OUI stands for Organizational Unique Identifier. OUI. It stands for Organizational Unique Identifier. Second, 24-bit, that is specifically assigned by each organization. That is assigned by IANA authorizations. That is IANA, that is specifically stands for Internet Assigned Number Authority. That provide the number to this 24-bit, specifically for this 24-bit. OUI, that means this address is specifically for vendor name. Who is the vendor of this? How we can check this? The vendor name, if suppose we have, so just wait, again I'm going to check my system's MAC address and we will check who is the vendor of this MAC address. We will get MAC address, we just copy from here. Go to the internet. So this is the website for checking the OUI part. Suppose here I'm just going to paste my MAC address, click on search. We will get complete information about this MAC address. Who is the name of the company for this MAC address, the complete address of this company, country code, date created, date updated. So this is the all information about this particular MAC address. Okay, so now we'll going to our slide. If we are talking about the Huawei has fixed OUI code, in the case of Huawei. But if we are talking about the Cisco that use different OUI code. Cisco they use only they use different OUI code. That is Organizational Unique Identifier. They will use different codes. Then after this, we have the unicast frame format. Unicast frame format. Again, it is the 48-bit and 7-bit this and this. So MAC address also 3 types: unicast, multicast, and broadcast. So unicast, that means we are talking about the one-to-one communication. It means we are talking about the one-to-one communication. So the biggest question arises here, that is how it will find out it is a unicast address, it is a multicast address, or it is a broadcast address. How we will find? If the 8th bit, or we can say first byte of frame, Again, I'm going to repeat. If the 8th bit, or we can say first byte of frame, if the 8th bit is 0, that means it's unicast. If the 8th bit is 0, that means it's unicast. As shown in this picture, after 7th bit, we have a 0. That means this is the frame for particular, that is a unicast frame forwarding. Unicast frame forwarding in this scenario. Okay, unicast means from one only one direction. Next we have, that is broadcast. Broadcast. So before explaining broadcast, I am just going to explain the multicast frame format. So multicast frame forwarding, that means we are talking about one to many, not one to all, that is specifically for one to many. As shown in the picture, we have 4 hosts. Suppose host A want to communicate with only host B and host D. They can send data frame host B and host E. So that communication is specifically for multicast. See, in host C, there is a cross connection. So that means only communication between host A, B and D. So that is specifically for multicast frame forwarding. That means one to many, not all, one to many. So after this, oh sorry, one of the 8th bit is, if 8th bit is 1, that means it is a multicast frame. 8th bit is 1. Because in the case of the unicast, if the 8th bit is 0, that means it is a unicast address. If you are talking about the multicast address, that means 8th bit is 1. That tells it is a multicast frame forwarding. So after multicast, we have, that is broadcast frame forwarding. So what does it mean? Broadcast frame, if all the bits are 1. If all the bits are 1, that means it's broadcast address. So if all the F's are, tells it is a broadcast address. As earlier I explained this, if the all F's are there in the case of MAC address, that means that is the broadcast address. Because that means we don't know about our destination's MAC address. If we want to communicate with X, but X is having a different MAC address, but we don't know about the MAC address, on that time we just deploy this MAC address as a all F's. So that means all F, that tells the broadcast. Broadcast, that is one to all. So before moving further, I'm just, so in this case, in the case of broadcast frame forwarding, we are talking about the MAC address. We are talking about the MAC address. And as I explained already, it's a 48-bit MAC address. So 48-bit MAC address, that what they divided into two categories. I explained already. 48-bit, that divided into two different categories: 24-bit and 24-bit. First 24-bit, that can be organization. And second 24 is the address of your PC. Okay. If we don't know about the destination MAC address, because we are having three different types of frame forwarding. One is unicast, multicast, and third one is the broadcast. How we will find this is our system's unicast address formatting, or multicast and the broadcast. If our 8th bit is 0, that means this address, that is unicast. If the 8th bit is 0, that means it's a unicast frame format. Second, if we are talking about the multicast frame forwarding, if the 8th bit is 1, 8th bit is 1, that means our address is multicast. That means we know about the destination MAC address. If we are talking about the broadcast means one to all. Multicast means one to many, specific person or specific IDs. One to all, that means broadcast address. That means all the 8 bits are 1. That means this is our broadcast frame forwarding. If we are talking about the MAC address, all 48 bits are FFFFF. That means as shown in the picture. That means it's our system's broadcast frame forwarding. Okay. So next we have after this we have the multicast address. That means our system's 8th bit. In the case of frame, 8th bit is 1. That means this is our multicast address. So after that we have the carrier sense. So carrier sense is also network protocol that listen to or sense network signal on the medium before transmitting any data. I'm going to explain again. Carrier sense is a network protocol that listen to and sense network signal on the medium before transmitting any data. So it works with CSMA, is implemented in Ethernet. Okay, so next we have the frame processing. So frame processing, if we are going to send a frame to any PC, so it will go with MAC address, source and MAC address for destination. So here you just see MAC address B, that is our system's destination MAC address, and MAC address A, that tells the address of host A. Then data, FCS, that is the frame checksums. After that, we have a summarized questions for this particular topic. So how does Ethernet determine the protocol to which a processed frame should be delivered? So correct answer for this, that is type field. First question's answer is type field. Second question, how is it determined whether a frame should be processed or discarded upon being received by an end device? How it is determined whether a frame should be processed or discarded upon being received by an end device? So correct answer for this, that is FCS. So FCS, again we explained, already we explained FCS, that is a frame checksum. So this is all about the frame forwarding, or we can say that the Ethernet framing. So thank you students for okay students, thank you, thanks for participating, thank you.